And we're live.
All right, hello and welcome back to the BCH Blaze series of streams. We did the introductory stream 2 weeks ago. We had the podcast with Jonathan Silverblood. We had our first workshop with Mathieu last week, and we're here for the second workshop, Quickstart with BCH dApp development with mainnet Pat. I'm your host, Jeremy from the Bitcoin Cash podcast, and BCH Blaze is a hackathon for Bitcoin Cash builders to get excited about Bitcoin Cash, to start building with BCH tools, to hopefully win some BCH. If you do a really good job, we have a 5 BCH first prize, 3 BCH second prize, and a 1 BCH third prize, plus also 1 BCH voted by the community using the Blaze Vote tokens that are airdropped to Jessica and Velma NFT holders. That airdrop has not happened yet, but if you have one of those NFTs, definitely keep it in the back of your mind because you will be receiving those before the live showcase stream, and you'll be able to vote on your favorite projects. So good to keep that in mind. We've had some feedback in the last couple of weeks that some people are concerned about our one and only requirement, which is to build using the Layla script upgrades, functions, loops, PayToScript, and Bitwise. And projects currently do have to have one of those included to be eligible for the prizes, although of course you're welcome to the first, second, and third place prize. But of course, you are welcome to build without them for any of the bounties that we have. We currently have 8 bounties listed, or for the community prize. You can also win that without using the new upgrades. But some people have said that they find it a very high bar, or just doesn't fit with the idea that they potentially had a BCH focused idea that was not going to be using those upgrades. And we have heard that feedback. And so we are considering what we can do to make things easier for people in that regard. I don't have an update on our exact solution just yet, but it is being considered. A couple of things for people to keep in mind before we get started today, which is to go and sign up on the Dora Hacks page. A link will be in the description, and of course catch up on the previous streams if you didn't see them and you're considering hacking as part of Blaze. There's loads of great information there about how the whole event will run, and we also have a YouTube video as well that explains in just 4 minutes what Blaze is. But all the information is on the Dora Hacks page, including links to those previous streams. So head there to get up to speed. Okay, we also have a cash stamp to give away. We've been giving these away on the stream. These are very cool little QR codes that you can scan with a BCH enabled wallet, such as Celine, and just grab some BCH. And they are a proof of concept in how you can help onboard people online, but they are also often frequently printed out on paper or on cardboard, like business cards that the BCH community use to hand around to people. You can find out more about them at stamp.cash and make your own. It's completely free, except for the money that you need to put into the cash stamps to give away. And I believe at the moment we have BCH support, but it will be soon coming to have cash tokens support, so that you can have Mori USD, or you could even have Blaze Vote tokens, or any other kind of BCH related token as well too. So thank you very much to the Cash Stamps team for sponsoring the stream and helping us out with the giveaway. The fastest finger wins when it comes to those. Okay, today our workshop comes from Mainnet Pat, who is a very, very prolific BCH developer. He works on Mainnet JS, which he will be explaining in more detail, no doubt, and also the marketplace at tapswap.cash. He has built BCH Pump.cash, a clone of Pump.fun from Solana and the Monero and BCH atomic swaps as well. So very, very capable and prolific BCH developer. Welcome to the stream. Pat, take it away.
Cool. Thanks for a nice introduction. Thanks for the kind words and appreciation of my work. So yes, today I want to speak about the Quickstart with the BCH decentralized application development, and as well in general the application development. And if you go to the next slide, I wanted to quote the Matthew from the previous workshop. He said that now is the best time to build on BCH, but every day is a good day to build on BCH, because building on BCH has never been that easy. So with every day, new tools, new frameworks, new capable people appear and make it better and greater to work on our network. And of course, our upgrades are so powerful and enabling, and we are advancing very fast, so that we really are in a very good place now. So I want to speak about the dApp stack. On the next slide. All right, not yet on the stack. So a bit about the BCH browser apps and dApps. So there are, we have seen already many, those which connect your private key to the application. So you import it like it was on dToken website. You create a temporary key on the app in the browser and transfer some money there. So you have limited security exposure to loss of funds. And traditionally, these are the self-custodial solutions where where the app owns the key and knows everything about the user. So can inspect the addresses, the UTXOs, and maybe as well expose user to the risk of being hacked by some operation system-wide, I don't know, worms or something, viruses, which would potentially steal this information and gain access to the local storage or indexed DB inside it. And even though the dApp is not malicious, the loss of funds is still there on the plate to be careful about. And yeah. So in 2023, I've been learning, trying to investigate about how do we separate the concerns so that the applications would live in their own sandbox, and the sign-in capabilities will be offloaded to a dedicated software, be it a browser tab, browser extension, which is more sandboxed even and secure, or be it a standalone application, which would be considered maybe even more secure. So there are layers of security improvements there, and layers of isolation of the application, and the private key, which possesses maybe even large sums of BCH, which is very harmful to lose. And I have started with Paytaka Connect, which was inspired basically by the MetaMask protocol, a window provider, which injects some special methods to the window context of the browser, and let's the developer communicate with this context and execute some commands, send some commands to the wallet to ask it do the sign-in and delegate the sign-in to it. So it was a nice preliminary steps towards the Wallet Connect technology, which did advance by that time to the Wallet Connect version 2. And it really improved on the first version, which was EVM bound and very limited and very, I don't know, not allowing user to experiment much. But Wallet Connect 2 stack was really flexible and allowed me to perform the first tests to kind of analyze if it is applicable for UTXO blockchains or not. So back in the time there in July, maybe in June 2023, I've been tinkering with it, and ultimately I have emerged with a specification on how BCH, UTXO, and Wallet Connect interactions would be established between the consumer applications and provider wallets. And in this sense, it is the application becomes non-custodial because it does not care how the private information will be stored, and in how much of security will it possess. And probably the best way here is that application concentrates on the logic, enriches the user experience, and wallets do their thing. They care most about the security. They make sure that the user won't be hacked. They keep up to date all the supply chain to mitigate all possible zero-day attacks and other types of hacks, so that the user will not be exposed to risk of losing their assets because of the application logic. Of course, there is still some due diligence which user must and caution which user must take in order to sign the transactions, only those which they understand, which do not lead in the loss of funds. But we assume here in this context that our applications are well behaved and do not try to trick the user into signing some malicious transactions, because we want to concentrate on building on BCH and not, mitigating all kinds of attacks, and maybe on the other hand, exposing users to be attacked. So the idea is here that security is delegated, and the signature signing of the messages of the Bitcoin messages and Bitcoin Cash transactions are delegated to external software, which is wallet here. And the application does not have any access to the key, can only see the wallet contents via connected address and propose user the actions, because only single address can be connected. The wallet exposure is as well kind of limited. This was a simplific approach which I have started with, that only a single address could be connected to as well. Minimize the amount of complexity this protocol would implement. But however, in my future work, I as well would like to introduce the HD wallet support, like hierarchical deterministic wallets with many sub-addresses, with change addresses and so on, so that the address reuse will not be an issue here. All right.
Pat, on that, can you just elaborate a little bit maybe on, you've kind of given a bit of the history there of how it moved from, PayToken Connect, Wallet Connect 2. Can you maybe just expand a little bit? I'm curious to get your thoughts on the Cash Connect work that is maybe going on a bit in the background, and also the XO stack that General Protocols have been publishing some information about it. There's no code that might not be suitable right now for this exact hackathon, but it's something I think it's important for people building in BCH to be aware of. So maybe just quickly your thoughts on how that ecosystem is going to develop, so that as people are designing their apps, they can anticipate maybe how things might improve in the future.
So I think back in the time when I have released the spec, Jim Tendo was kind of digging into it and being interested in it and willing to explore the templated actions or interactions of the dApp to the wallet with only whitelisted or allowed or recognized templates. And this as well kind of spawned a side branch of my work and different specification, which is Cash Connect. It is, as I recall, still in some early stages, but still it is used in a production application, which is BCH Guru. And as I understood, the Wallet Connect 2 approach did not allow the BCH Gurus to shine enough, so function properly, so that they were very happy to adopt James's Cash Connect. And with regards to XO Stack, I think I will show you how my approach in the work I present to you today is basically not bound to Wallet Connect. It will allow you to kind of isolate your application logic from the sign-in methods, sign-in software, be it Cash Connect, be it XO Stack or whatnot, because it is universal approach to separation of the application and the sign-in software. All right. I hope that answers your question.
Yeah, brilliant. No, that's great. That's I'm looking forward to, like you say, things are always getting better in BCH, yes. And it's just great to see the next thing and the next thing are already coming. So the more people can get involved, they know that they're already going to be on a rising tide, right? So anyway, that's perfect. That's great.
Right. As a bit of background, why I have picked this up kind of 2 years after the specification was created, it is basically because I constantly work with this software, I constantly improve on it, and it's like I always keep a backlog of my own wishes. How would I improve the current situation? How would I make the software more testable? Because when I have first implemented the Paytaker Connect and Wallet Connect with TapSwap, it was really like field testing. You always need to reconnect the wallet, do mainnet transactions, hard to debug. You need to cover all the edge cases. You constantly improve on the contract, and the base on which you build it constantly changes, and it's hard to keep track of. And then this summer, I have been working more with this separation of concerns, and I have seen clearly that I just need to keep using my own tools like mainnet and CashScript, and not concentrate on the Wallet Connect stuff, on the sign-in stuff. And this kind of spawned an idea for me that I really should formalize the interfaces, revise them, and make it more testable, first of all. And I will show you, as I will progress throughout my presentation, how we land to the present days where everything is like a bundle of testable software, where you do not need to test in browser, but rather you test in your local isolated environments first. All right, let's advance. So here's a typical and simplified application stack for browser applications, but these are not actually limited to be browser applications. This could be as well desktop applications. So first we start with the user-facing application interface like TapSwap, like, for example, where you have a list of contracts, swap contracts, like you swap the NFT of this and that kind with this and that amount of BCH. And in order to kind of, for the user, in order to take this offer, they need somehow to communicate with the application. And application prepares prepares the transaction sign-in request for the user, which on behalf of the user gets sent to the connected wallet via the connectors. And of course, we have started with the Wallet Connect 2. And currently, I as well work with the self-custodial private key connectors, which as well are browser-based with encryption storage and so on, encrypted storage. And so this is already a kind of a novel connector type, which as well could be on the place of the self-custodial private key. There could be XO Stack or Cash Connect, sign-in, and so on. And via this connector, the sign-in request goes to the sign-in software, like CashNice Wallet Connect 2 enabled wallet, or private key in case of local testing environment, and maybe other potential signers. And what it does, basically, it boils down to, for these signature requests, boil down, of course, mainly to BCH transfers to pay for goods or something else, and contract interactions, like in case of tap swap. And as well, in case of tap swap, BCH transfers would be the consolidation of the UTXOs, so that this is a pure BCH or pure BCH cash token UTXOs, which got merged into one output, having more funds to be paid to something, right? And I will cover now on the next slide the BCH transfers. And for this, there are many software tools existing already, which facilitate the transaction building. The most basic and low-level primitive operation is for the defined in leap-off by Jason Dreisiner, and this software is very low-level, and probably a newcomer would never succeed into building a transaction, signing it, and propagating over the network, because it's too much of even technical knowledge required there, not even taking into account the templating functionality of leap-off, even just in pure function calls. There is as well the PSF BCH.js library by Permissionless Software Foundation. It is an advanced package of utilities which allow for transaction building, wallet interactions, as a REST API, and all other gimmicks. So it's a full-fledged software piece, which allows one to facilitate the BCH transfers. And I here highlight the mainnet.js. It's our work, and I will cover it in a bit of details in the next slides. But of course, this list is very limited here for the presentation purposes. There is every day, maybe every year, of course, there are many tools, many packages appearing, trying to kind of revise the older approaches, modernize them, capitalize on the novel approaches, on the newer typing system in the TypeScript, and so on. And of course, I cannot mention here all others. So on the next slide, I will.
Can I just jump in there? I just want to add one example like of that for people who are not familiar. So one thing could be libraries in different languages, right? I believe there's one developed by David Shattuck in C++, and also in Selene, which is open source, and it's built in JavaScript. So we haven't extracted it into a documented package, but the code is there. Anybody can look it up and find the section where Selene does the transaction signing and builds the transactions and so forth. So if you need a reference for trying to send a transaction, that's also just another place that people can look.
You are very correct here, because I explicitly cover only the JavaScript-based and web browser-compatible tools here, because I mostly cover the dApps, and dApps in common sense are now the web applications, the browser applications. So a couple of words about the mainnet.js. That's my signature project, and the project where I came to BCH community at all. So I was busy elsewhere, but then Simon from Mainnet Cash and ReadCash asked me to come over and take a look, and I was like amazed, and I have seen how Bitcoin has advanced, and the tooling around the Bitcoin has advanced, so that it was. I was never programming Bitcoin, but I of course knew the technology, and I have seen on the example of this library back then that it is easy, and a newcomer like me, of course with the coding experience, can just jump in, not only working with it, but contributing to it. And I was amazed how easy it was back in the days as well to add new features to the well-established package and cover new feature requests. And I was really amazed that the tooling was already that mature in 2020. And I was happy to work with this, so that I have ditched my full-time job back then and switched to the best BCH dev full-time. And there was that was the most right decision in my life, I would say, because I'm so happy and fulfilled working on all these projects and inventing new stuff, finding new stuff, like thinking about it. It's really takes all my time, and there is always something new which I would like to take on and maybe invent something new. It was I need to admit to you, when I have been developing this debugging tools, it was like I was asleep, and it just struck me in the middle of the night at 3 a.m. that, God damn, it should be possible. And then I just started working throughout the night, and by morning it was a functional prototype. Of course, very ugly, breaking stuff and so on, but the concept was proven. And I mean, those ideas, they come out of nowhere, and they inspire you, and then you lose your mind until it is finished. And that's a bit of my passion here. So I'm very passionate about this stuff. So mainnet.js is built on top of the libauth, and because it's a building blocks, mainnet.js is kind of a sandbox of all these building blocks, and we just put them on top of each other to a fancy tower, and we execute the logic, and we get the functional wallets, and we use the Fulcrum for network interaction. Fulcrum is a nice and fast indexer by Kalin. We use it as an on-chain data source, and we use it to query wallet data on demand. So to say data available, but as well monitor live events, like we are waiting for transactions, balances, blocks, or we watching them arrive live on the network. And this is very handy in in improved user experience applications, where you get notified and you do not need to kind of wait and guess and refresh the page to see the new status of your order. You always can be sure that you will not miss your transaction, be it a deposit to your service or something like this. And mainnet.js supports all the networks. It's highly configurable. Main network, of course. ChipNet is our default testnet. We ditched all the other testnets for good, because ChipNet has all the most recent goodies. And of course, we want to capitalize on them and want to explore and let others explore with our tools on the ChipNet. And regression test is very handy. We ship a package to bootstrap the regression test. This is a very special test network which you can mine on top of with 0 CPU power. So you can just advance your kind of sandbox network as you please. And this is always was essential for the mainnet.js to has its as well the speed of development, because testing against main network is not that insightful at times. So regression tests is very cool. And there is even more novel approach is the mock network, which is based on evaluation in the cache VM in BitAuth's virtual machine implementation. So you do not need even to run a BCH, let's say, to validate your transactions. Of course, it will not enforce all the consensus rules and so on. I mean, it will enforce the consensus rules, but it will not do all the checks the full node does, and there might be some differences in transaction handling, but you will be sure that your transaction scripts in the inputs were executed correctly as they would be in the Bitcoin BCH full node virtual machine. And this mock network provider is available in CacheScript, but not yet maybe in mainnet.js. That's a nice idea to as well enable it on mainnet.js for even faster test suite runs. Okay, and mainnet.js as well provides advanced tooling, including the REST API for those which do not work with JavaScript. for Python, maybe for PHP, they can just capitalize on communicating with the REST API, which main.js provides. There is support for WebSockets and webhooks as well. This is some advanced stuff. And maybe not that popular anymore, like webhooks. And it is the tool powering most of my projects, because of course familiarity and personal attachment plays a role here, but I find it most easy to start any new idea with just throwing in main.js and starting experimenting. All right.
Absolutely. All right. On the next slide, we do have another cash stamp. So if you've had your wallet at the ready, you can pick up some sats there. And I do just want to say I love that story about working at nighttime, having the idea at 3 a.m. and stuff. I think that's common to a lot of software developers. It certainly happens to me that I go to sleep thinking about an idea, or maybe not thinking about an idea, and then I wake up in the middle of the night with it. And definitely a few of the projects I've worked on, certainly including Selene, there's features in there that just, I got up at 3 a.m. I just couldn't go back to sleep because it was just burning a hole in my brain. So I just get out the laptop and there you go. A lot of writers as well, like, you know, comic authors or novelists or whatever, they also like that vibe of 3, 4 a.m. when it's really quiet. There's something about that time in the day that gets people's creative juices going, you know?
Yes, because there is always this background thread of thinking where you do not only work on the current stuff, but where you always have the backlog inside your mind that you would revisit and think about new stuff and so on. And the most pity thing is that you are occupied, that you need to finish the current project, but it already itches to start the new stuff. So kind of, you cannot clone yourself, so that it's a pity. All right. So for BCH transaction interactions, I already have sent the transaction transfers in the framework of my presentations are facilitated with main.js, and contract interactions are possible in browser and in other environment with several frameworks. There are not many because of the complexity of the software and the amount of competence required to jump into this topic. So there are these frameworks, CashScript, which Matthew did cover the last time, or touched the last time in more extent. So it's a Solidity from EVM world and JavaScript-like syntax to define BCH smart contracts and covenants and enforcing rules inside those contracts. It has a lively community, actively maintained and improved piece of software. And of course, because of that, I have decided to base my work on the CashScript for the dApp interactions. There is the Spadden project by Tendopain, which is not that maybe loud around it. So it's more like a C# and Rust-like syntax. And maybe I'm being subjective here, but it's not so often used. I do not hear about many projects using it. And then there is this novel Alba DSL, Haskell-based projects from this May by a brilliant guy. He is, I've checked out the project, and I was overwhelmed by the complexity of it. So, and the Haskell is as well needs functional thinking, right? Most of us think in procedural terms, and Haskell is something else. And and there is this Alba VM virtual machine which allows to evaluate those contracts in Alba DSL, and of course, because of obscurity of those tools, they are not really accessible to everyone. And my idea in my work here is that I would like to take the complexity associated even with the easiest tool, with the CashScript, from the users, so that they do not need to set up and bootstrap the programming environment. They just open up the template and start with their idea, because idea first. It must be like followed, and you should not stumble upon all the complexities and give up on your idea. You should be able to achieve your goals with less strain. All right. So the last level is sign-in. So we describe here two types of sign-in: the direct approach. The app needs to know your private key, and this is no bueno. You do not like to give up on your key ownership and share it with some applications, be it like trust me, I'm fair, or I don't know, something obscure which tries to exactly steal your funds. So it's never a good idea to share your private key, not your keys, not your coins. Remember this always. And there is this approach of delegated share sign-in, which I kind of use these terms. You use sign-in connectors. You prepare specialized signature requests to annotate which parts of the transaction needs to be signed, like which inputs, which parameters of the cash script contract, and so on. And the sign-in software is already smart enough by the present work to recognize these requests and insert the well-formed signatures in right places so that the transaction validation passes as if you would sign it by yourself. So to annotate this signature request, we use a placeholder approach. We put 65 bytes of zeros to indicate the signature, a Schnorr signature to be specific, and 33 bytes of zeros to indicate pub keys. Because if you adapt, you do not, of course, know what is a pub key behind the pub key hash, which is a public information, but pub key is, of course, will be uncovered only by the first spending of the coin. So it's we must assume here that the pub key is not available to the dApp. And signature is, of course, the most crucial sacred piece of information, which signature construction is the ownership of the key, basically. All right. So sign-in is the crucial part. And to arrive to signatures, we use the connectors here. And those connectors recognize the placeholders I have just described just recently. And the connectors, they do the actual sign-in. And in terms of sign-in, right, we use the private connector. Like you would basically use the private connector on the wallet side, right? So you, for the like network connectors, like a Wallet Connect 2 connectors, you would use the network infrastructure to get the signature from somewhere, and basically you can just embed this piece of software, which is private key connector initialized with the private key in the wallet, and it will get make you the sign-in, right? And another big benefit of it is that you really bypass this network interaction and in-wallet sign-in, like with the nagging pop-up windows and so on. You just go to the point, and you speed up the local development. Like you, of course, in local development, you know the private keys you would like to test with, and you just initialize this connector and cover all your test cases to kind of harden your smart contract and not to be hacked or exploited, and cover all the kind of require statements and so on. And of course, these network connectors like Wallet Connect 2, they are for you could see that they are for use in production. So there is no sense to use them in testing, because your testing times will just grow by factors. And those connectors, they just facilitate the sending the signature requests to a sign-in software. So, and of course, we could extend those connectors with XO stack or Cash Connect stack and so on. So,
Pat, we've had a question in the chat from Ken, right, who says, what is the flow for deploying and calling a contract on CashScript for an EVM background dev? So I assume being an EVM background dev, people are more familiar with this idea of writing up the contract, deploying it onto the chain, and then having people interact with it. But in BCH with the UTXO model, it operates quite differently. So maybe you can give a quick summary of that for somebody who is thinking in an EVM way.
The common idea about deploying the BCH contracts is that you just send some money to some address which you know beforehand. But it turns out to not always be correct, because when I have ported the sushi bar contract from EVM to BCH, it's already a complex contract with certain state, so that in order to deploy it, you need to deploy 3 subcontracts, so to say. You need to initialize the state on the NFTs of the cash tokens and so on. So suddenly it becomes more complex than just sending some funds to some fancy address. It's really multi-step process, which is the same on EVM. It's just hidden from the user. Internally, all the storage slots will be pre-initialized for you, and you will never see that. It will be just, you will be paying gas for it. But on BCH, we really do sometimes need to make multi-step processes to really deploy the contract. This is why I will be using this term here throughout my presentation. I will put it into quotes, because for BCH it's kind of a bit of a special meaning, but really it is some process, be it as simple as sending some funds to an address or not. And if you are eager to learn about this complexity, just navigate to my GitHub and look up the sushi bar contract repository, and you will see that it is indeed more complex than that.
But there is also the cash script playground, right? That's somebody who is brand new to BCH. Maybe they're not going to start with the complicated one. Maybe they have a lot of experience.
This is what I meant. Even with the cash script playground or the testing suite, which I have authored, which allows for this kind of setup to be formalized in certain series of initialization transactions. You would see that it still requires some handling in some cases, all right?
Ken says, what is your GitHub? It'll just be github.com/mainnet_pat, right?
No, minus pat.
Mainnet -pat, yes.
Yeah, right.
github.com/mainnet-pat.
And then sushi bar.
Sushi bar.
Yeah, I should have put here the reference to them. All right, so that's for the connectors. So, and then once again on the dApp level, the app itself does not need to rely on knowledge of connectors. So it's an interchangeable piece of implementation. So you could, for example, the same software would be interacting with test connector when running tests, or with real connector like Wallet Connect 2 connector when going in production. So this is the idea behind this, that these connectors, they are interchangeable. So, and the application should only care about proposing the transactions, proposing the signature requests, and wait for response and handle the successful or unsuccessful responses. And this really simplifies the application design, because even when I have started with TopSwap, I was really having the contract interaction kind of baked into the React app, and you usually do not like to mix just your TypeScript with React states and so on, because it really becomes headaching, right? Inducing the headache. All right, so this is the idea: simplify the interaction of dApp with the contracts. So, and for this, I have prepared the set of packages called @BCH-WC2. Back then, when I have chosen the name, I was mostly thinking about the wallet connect interaction, but basically it is really with the concept of connector, you are not bound to wallet connect only. So maybe the name is not well suited for now, or maybe became not really well suited, but still it's a collection of npm packages to implement the described stack and the approach to interact with the BCH network, be it transaction signing or contract interactions. And it aims to abstract away the connected signer and allow to develop universal software. So because why I say universal software, because if it would be server-side software, like where user does not need to bring up the wallet and sign all the connection requests, it still would use some delegated signing, like for this secure walls on the processor where you can put your private keys to and delegate the signing. They're guarded maybe by thumbnail, I don't know, by your any means of authorization, be it Face ID or something like this, or maybe in automated fashion, right? So the idea is to abstract this away. All right.
And we have our next cash stamp. So we've had a few people in the chat. Bruno, shout out to Bruno, said, suggestion, if you grab the cash stamp, donate it right back. So, of course, we would appreciate that. But if you are fast enough to grab the next cash stamp, consider yourself a winner and maybe just hodl those sats. But, of course, we do have the donation address listed, and 50% of the funds donated to that will go into the Blaze prize pool, and the other 50% is used on operating expenses to run the event. So if you're watching the stream, you're enjoying this content, you're getting a lot of value out of it, then maybe just send us a few sats, experience the power of BCH that any random person on the internet can help you send money in a couple of clicks. All right, moving on.
Right. So I just been reflecting on what I've been conveying to everyone, and I just want to step back and give a greater picture, maybe a bigger picture about what I'm saying. Because so far, where is the starter? Where is the template? I mean, of course, it is there, and in order for me to ship such a template, which is easy to start with. There is a lot of kind of preparatory work needed to be done so that user sees less code and be less scared about the complexity of it. So really packaging it all together enabled me to create this template in the end effect. So I will just cover the sub packages briefly, which help us facilitate this delegated signing. And of course, we start with the interfaces, because when you declare some abstract signing piece of software or signing interfaces, you really need to describe what is being like the message datagrams and what are the interface of this universal connector, so that your TypeScript application understands how to interchangeably use this or that connector so that it conforms to the interfaces. And also in this, as well, there are some extra interfaces, not only for the BCH fund transfers, but as well for the cash script interaction, where you declare which contract are you interacting with, which parameters are of which type, and what is their order, and so on. And this is essential if you need to interact with the contract. You need to be very specific about how it should be interacted with, otherwise it will just fail for you miserably. All right, let's move on. So the private key connector is, I have been already, I'm actually constantly speaking about this stuff throughout my presentation. And this is the essential part for those who explore the idea first. They start with a contract. How simple could it be? It doesn't matter, but still you need to be able to start testing it, like shaping it. And my common approach is that I developed by testing. So I advance in steps. I constantly check that the idea which I evolve, it conforms to the rules, and when I add new stuff, it does not break the stuff already implemented, and this is kind of ensures the integrity of the software which I work on. Of course, it's a crucial component for local development and testing. Let's move on to Web3 Model Connector. This is actual Wallet Connect implementation, which uses the sign client and Web3 model for QR code rendering. And it is also it's a bit outdated already. There are more work to be done to use the new Reown kit. Wallet Connect company did rename to Reown, so they ship now the new AppKit software. So we should soonish transition to this software, and there was already some work done by our fellow collaborator, and they post on Bitcoin Cash research site. And this approach should be then moved. We should move to it. And the beauty of this connector approach is that as soon as the new connected with the new Wallet Connect Reown kit will be ready, the transition should be seamless. You just drop in the new connector, initialize it correctly, and then you do not need to change any logic of your app, right? And this is the entire idea of this connector stuff. And this Web3 model connector I ship with already pre-configured to connect with Cashionized, Paytaka, and Zapit wallets, so that they are opened up correctly, and the connection information is presented to the user and formed correctly. And it's for React.js. And imagine you would ship as well the separate connector, or maybe more universal connector, which would work with Vue.js or maybe with other frameworks. So here's like when you have the basic idea, you just need to package it for a certain framework, and it must work. Right, and of course, the cool thing is that this Wallet Connect standard, it supports mainnet and chipnet. It does not really is not meaningful to use the regression testing network, because I don't know. It's like you should instead just use the private key connector for that. Good, but when we will be anticipating when the chipnet will have the new upgrade activated, of course, everyone will be testing on the chipnet against the full nodes with new consensus rules updated and enabled. All right. And there is some cool idea of mine. I always thought that it must be possible, and it indeed is possible to wrap the mainnet.js wallets with these connectors, right? And go check out the mainnet.js documentation. There are many methods which are for sending funds and so on, which require the private key. But here you could create a wallet which is watch only. So this is like you are spying on someone, right? And of course, you cannot impersonate them without knowledge of their key. And here the idea is that I create the private key connector and attach it to the watch wallet, basically creating a full-fledged wallet with signing capabilities. And you just interact with the mainnet.js in the same terms, but you will have more options like user prompt and broadcast available for you, because these are custom extensions which are for the connect, which are defined in the connector interfaces. So you kind of enhance already existing functionality for the mainnet.js. And under the hood, it basically builds the unsigned transaction and delegates the signing to the connector. And if you will provide the Wallet Connect 2 network connector to it, it will be the entire interaction with the remote wallet will be hidden from you in just this .send invocation. And this is really a step forward in comparison what I had in TapSwap back in the days, where I need to do all this juggling by hand, and it was like really sheets of code. And now it's like you really write universal code, which works same on the server side with the private key provided or with some delegated signing. All right, and the same trick I did apply for a transaction builder of CashScript to create a CashScript signer. You just create the contract as usual, but you, instead of providing your own pubkey hash, you know the pubkey hash of connected wallet, because remote wallet provides you the address, and this is basically the hash. You then instantiate the connector, which is in this case, it's basically the real test case from the repository. You provide the private key, and then you just write the same transaction builder. You shape the transaction the same way you would, but instead of providing real world user information with the knowledge of their credentials, you would provide the placeholder public key and placeholder signature instead of signature template. And then you wrap the builder with the connector and just invoke the send, and it will do the same stuff as if the private key was provided to this software. And as well, behind the scenes, it will do all this network interaction with the remote wallet and do the actual signing on the wallet side. So it really is not only quality of life changes, it really is the kind of paradigm shift that you write universal software instead of doing kind of two sets of code, one for local testing and the one for production use. All right, let's move on. And I come here to the summary of this package. So it really allows to create the application code agnostic to the sign-in connector and able to abstract away all the hassle in them. So, and of course, it offers to the developer to concentrate on contract development first, like idea exploration first, and testing it in the testing suite from CashScript, and not on the live network with all the wallet pop-ups and whatnot. And of course, as I mentioned, this makes the UI development easier, where you need to just write the UI code like React state manipulations instead of writing all this, I don't know, wallet interaction stuff and so on, because it will be hidden away from you in the sub package within this template I mentioned. All right, so, and here we come to the dApp starter template, which I have, I want to present to everyone now, and it is public at this URL. So it's a small workspace of two packages, like for the Node development, Node.js development, for contract development in testing suite, and the UI code itself. So they are separated. And the UI is minimally styled, so that just for the purposes of the demonstration, I just did not import any other components, libraries, and so on. For you to concentrate on copying away some stuff, or maybe inserting your own styling into to this UI app. And then it, of course, demonstrates the contract development and testing patterns with the connectors, as I mentioned, and connector usage in the UI, of course, in React.
Amazing. All right, we've got one more quick little cash stamp while Pat gets himself ready for the live demo. And I'd like to note as well that for Blaze, you're completely open to use this template, any other template, any kind of library, any kind of AI, any kind of scaffold You can use whatever you want. You can work on an existing project that already exists before the hackathon. We have absolutely no restrictions on anything like that. But if you are building on something like that, you just have to acknowledge it at the start so that it's clear to the judges this was the pre-existing work or template or libraries or scaffolding, whatever that you started with, and this is the new thing for the hackathon. But if you find this template powerful and interesting, definitely start your Blaze project on the 15th of November, load this up and go for your life.
All right. I will share my screen now. I'm sorry.
Streamception. All right, I can see that. Pat, are you muted? Did you mute yourself?
Oh, I'm sorry, I forgot to unmute myself. All right, so this is a pretty simple app, not very pretty because no styling applied, no components imported, and so on. So basically, it has this connect wallet button with extra functionality, but it really does facilitate the interaction with in my case, with the cachionized wallet. I'm sorry to present it in development mode. I had some issues publishing it on Vercel in time, but I will resolve this later so that it will be accessible for everyone, and I will update everyone on the new URI. So we just click the connect button. Here are the pre-configured buttons for cachionized Paytag and Zapit. But instead, I will copy the link, the connection link, and I will go to my favorite fork of cachionized, which is called CC Wallet. It has some extra functionality to swap the tokens right on Cauldron, right in the cachionized. So this is my preferred way to interact. So I will connect the dApp now with cachionized. It's called very foobar-ish. And it shows now the connection is established. It shows the connected address. It shows the wallet address and as well some assets which are connected. In this example, I already integrate the metadata handling of the cash tokens, like the BCMRs are fetched from the network, and they are used to render those icons, the names of the stuff of the tokens, and as well the decimal places are as well very important here. So I have a big collection of everything, just to demonstrate to you how it might look in your application. Right. So you could even go past that and implement the price fetching from of the tokens from the Cauldron, maybe as a homework for you. I know it's possible because I implement this in my other projects, so maybe that's a challenge for you. So in this Quickstarter, I use a contract which is a pay-to-pubkey hash, but dropped into the P2SH, right? So it's a bit obscure, but it really is the most simple contract which highlights the usage of both public keys and the signatures in the contract, so that this placeholder replacement approach shines here at full. So, and you see that for me, my personal contract address is this. For you, it will be different. It detects that no UTXOs exist in here, and the UI offers me to deploy a new contract instance. And it could be not a single one because we are on UTXO world. And yeah, let's deploy. We see here the signature request. It went over the network to cachionize, and we sign it here. We go back. It's the contract is deployed successfully. Now we automatically, this is the shine. This is where the manager shines with watching the live activities on chain, because as soon as Fulcrum Indexer sent us the new activity recorded on network, we updated. So we can even add more. Let's add 2000. So there will be 2 UTXOs available to be spent, and so on. We could check for some sanity, like the contract will fail to deploy because there is a rule inside the contract that, or in the deployment routines, that a minimal amount should be met, or we can try to deploy too much of a value, and of course there is not enough satoshis available, and all these cases they are being caught in the contract, in this testing suite where we deploy the contract. So you see already there are a number of edge cases which you might stumble upon and want to handle gracefully. So these are all handled in the testing suite environment where you develop your contract locally before moving it to UI. Because in UI, you do not need to handle all these errors. You just need to display them, and it's like makes it much more easier compared to handling this edge case, that edge case, and whatnot. So let's say we want to spend, I don't know, let's spend only 1,000 or 1,100, and this is my address, so I send it back, spend it to myself. But of course, you can spend to everywhere, to any address, and you see that now I have much less satoshis than there are available, and I can dissolve the contract from existence by spending all the rest funds from it. And there is no contract existing anymore unless I will redeploy it once again. So this is a very simple demonstrator on how to interact with the contract, or with a packaged contract. Let's call it like this. So we
Pat, we've had a question which I think is relevant to this. Is Carl says, can you send cash tokens to the contract with this?
Yes.
Like you were showing the satoshis there. Can you show an example with cash tokens maybe?
I did not have it prepared, but of course, this contract is intrinsically capable of sending cash tokens. This is a perfect example where you do not need to reinvent the wheel or need to like work with a separate contract. You can take the template and enhance it with a little work to support the tokens. And on the cash strip level, there is just an extra caution need to be done that you send to a token-aware address. Otherwise, all the handling is basically the same. So all these tokens which I had on my tab, I could have locked in those UTXOs. But for simplicity of today's presentation, I was really concentrated only on the minimal digestible amount of complexity to be presented.
Yes.
Okay. All right. And maybe I can give you an overview of the code.
Yes.
Which is packaged behind this UI. So I will share my Xcode. I hope you see it.
Yep. Seeing Visual.
All right.
Visual Studio, yeah.
Suddenly I see, okay, this here. Oh, that's the wrong window, is it? Which one do you see, the BCH-WC2 or not? Or the dApp window?
This one is a pretty low resolution right now.
The dApp starter, I'm seeing the dApp starter.
Yeah. Is it like not comprehensible for you to look into it? I can try to resize the window.
No, I think it's the dApp starter that we can see.
I mean, let me try to.
Oh, that's perfect.
Better,
yeah.
Right? And yes. I will increase the font size. So we will not look at the UI at this moment. We will look at the contract directory, and this directory is basically the testing suite from cache script repository with little enhancements. You can see package.json for the scripts, like how to compile, how to test, and everything, right? So you do not need to be expert on this. You just need to issue one of those commands to build, clean, compile, or test. And in this listing of the subdirectories, of course, there is most important the contracts directory with the contract itself. You see that it is super simple. It's basically the pay-to-pubkey hash contract, but expressed with in a cache script syntax. You see that there is the contract is initialized with your pubkey hash so that you will get it unique. And in order to spend it, you need to provide a public key and a signature. And these are two requires which enforce the virtual machine rules that hash of the pub key must match with the pub key hash, and the signature constructed from pub key and sig. So the signature constructed should satisfy the check sig rule. So you see that it's a very simple contract, and with a yarn compile, it will compile to an artifact here, and this artifact describes the internal representation of the contract, which will be fed into the cache script contracting system. All right, so you see here that there is the src folder or directory which has the index with imports. It has some utilities which are just making it, helping it run, and inside the contract and the contract name. So I explicitly structured the directory listing to have the contract, then its deployment function, its functions to be invoked, and this corresponds to the definition of the contract, like spend. The name is here. It's easier to read it, right? And then these two functions are being kind of embedded into a class, and working with a contract class is easier when you kind of try to encapsulate everything. And here you see, of course, you need a connector and a wallet, and the wallet here is used for the means of pubkey hash provision, right? You see that for static method of deploy, you just invoke this function declared in the deploy class or class file, and you basically return the new instance with deployment. And if you look into the deploy function, you see that there is no contract interaction. It's just you create a signer by wrapping the wallet with a connector. You create the contract to know to which address you need to send. And then this is the quoted deploy contract, because this is the simple way to deploy. Yeah, you just send some satoshis to this address, pre-computed, known well before, and this is your deployment, right? No state initialization, no sibling contracting deployment, and so on. Pretty straightforward. And as well, you define here some user prompts and whatnot. And the spend function is a bit more heavy because it has some business logic in it, right? You need to constrain the edge cases. You check for negative values. You check for contract total value so that you cannot spend more than you have, and so on. And the same, you create here the contract. Then you construct the transaction builder. You add the inputs of all deployed contract instances, and you output to yourself. This is formulated in very, very basic terms. And here you see the placeholder public key and placeholder signature are used to initialize the unlock spend path. And a lot of change handling and whatnot, so that you do not overpay or underpay, so that your transaction will be picked up by the node and not rejected. You report on the fee per byte for sanity checks. This is the bug, you can disable it. And then the builder, which you have defined here in two simple lines, you just wrap it with the connector and issue send, right? And this is very easy. I here ask to not broadcast it by the wallet, by the sign-in side. There is an issue with cache script I have reported just recently. But I just want to have full control and send the raw transaction which was provided by me to me by the signer, right? And I just send it, right? And I'm sorry, if it will throw, I will catch it in my UI. So no need to encase it in try catch clauses here. So it's really becomes more straightforward. And then I return some extra information about this spend function. So really pretty easy. This is the implementation of the spend, right? And this is how the test will look like. Shared test contract P2PKH deploy. So I deploy the contract with some Satoshis, and I check that the UTXOs exist on the provider. Very easy tests, but really this is very declarative on what you set up and what you expect from your function to deliver you. And then for the spend, it's a bit more rich on logic. You see that I create the provider, I mock the wallet with the mock network so that I do not need to communicate with the live network. I create the connector with the private key. I do the deployment of this contract. I try to deploy, here I test this edge case that I deploy less than allowed, like with 900 instead of 1000, and I expect it will reject and throw. Then I deploy just usually just with enough funds, and I say that we can as well send to some more funds there instead of deployment. Because we know the deployment is that easy, we can as well make a different kind of deployment, so that there are two UTXOs on the contract. And then we just spend those UTXOs, and when you see here spent, everything is hidden from you, right? No connectors, no wallets, no nothing. The complexity is hidden from you here. And this is how it will look like in your UI code. So you just say spend and expect some result. You actually do not even analyze the result. It will be reflected for you in the UI by the watcher, right? The thingy which monitors the contract address. And if it throws, it throws. Let it throw and just display a meaningful messages which are defined in the spend function, and they will be information rich. So it will not be some obscure transaction rejected by the network rules or whatnot, because you know most of the cases and you have handled them gracefully. And you just check that recipient did receive the payout, and you check that the balance on the contract is this and that. So this is really the kind of a business logic. So there are two cases: to spend some funds from all UTXOs and spend all funds, so that there is no change left on the contract which is above the last limit. So really some handling to safeguard the user from some undesired interactions with the contract. And when we look at the dApp code, it's a React Next.js application. And I would like to show you how the embedding of the Web3 model provider look like. So basically, this is your the layout is the entry point kind of for the application where you define the HTML body and whatnot. And I here put the provider in a separate file. I'm sorry. And it will contain this Web3 model connector context. And here is your Wallet Connect project ID. You could as well add here if you would like to use the chipnet, if you would like to define extra desktop wallets or narrow down this selection of 3 to only customized, maybe we can define here the rich metadata, which will be rendered on the wallet side. So some extra configuration, but here for simplicity, I just put the required only stuff. So initializing the connector is very easy and straightforward. And on the main page, we make use of this context, and we do not need no fancy methods like sign transaction, connect, disconnect, whatnot. We just grab the connector and the address. I as well do wrap the connector in the try catch, where I look for any issues. And if there are any, I show just with my native applications pop-ups that there is it's just for more fancy failure handling. And this code is pure UI. There is nothing about connector, nothing about the contract. Everything is uploaded here to the connect button and to the P2PKH view. This is the contract interaction ways. For the connector button, I render here all the assets which were loaded. And here, once again, I use the connector context. And here I check for, was it connected? I grab the address. I take the functions to explicitly connect and disconnect, some loading state handling. Here I use the hook for with main.js watching stuff, so that the UTXOs will be updated gracefully as soon as they arrive to the indexer. I compute here the total balances by token. I track the categories. I track some state of how it will be presented. Here is how I add the missing BCMRs, right? Because in the public folder, I could already embed some BCMRs, which I do not expect to be changed ever. So to reduce the network loading times. But here I will fetch them from the network. And the entire complexity of handling the BCMRs and token metadata is hidden just behind this call. And your token images and so on will be available for you to be grabbed by, let's say, get token name, get token image, and so on. And this is everything defined in the utilities. So for those coming just to build and not to be overwhelmed with the complexity of, oh, what the hell is BCMR? How do I fetch the name, the decimals, and whatnot? Just it's just the presentation layer, right? There is no business rules here, but still you present the user experience, the rich UI. So you would really want to handle this. So this is for the connect button. It handles the connect and disconnect with the connector. And for the P2PKH contract interaction, I use basically the instantiation of the contract. This is the hook, which just takes an address and the connector, right? So it's very easy to instantiate it. And I just here instantiate the contract from the contracts package, right? And it will have all the functions already there, right? I can ask for the UTXOs and display them. And here it's just for every contract function, I just use a handler for the button press, and I just simply take the value with which I need to deploy, and I just say, okay, just deploy with the following stuffs. And I show like success info on success and failure reason which is already well formed from the contract package, right? So all these handlers, they suddenly become only UI specific. They are less about the contract, they're less about the network, less about the BCH. This is like a React code. You just handle the value inputs and input values and so on. Same with the spend. You just grab the value, you grab the recipient, and you invoke the function. If it throws, you show the error. It is as simple as that, because you do not need to write all these countless lines of code. And here's just your normal React code to render stuff. So with this, I really would like to underline that it really became much more easier, from my own experience, much more easy compared to 2 years ago when I first started interacting with contracts on BCH. So this encapsulation really helps the simplicity, and the testability with the testing suite is superior to the times where I need to test everything in browser. So this concludes my demonstration, and I hope it was very informative for you. I will end my demonstration.
Fantastic. I mean, so clearly you just had that file with the cache script and the spending conditions, which was just the private key, the hash check and the signature, and then people couldn't get started. They could just use your application, fork it, start it up, and then just be playing around directly in there with their own spending conditions, and they're already rolling, right?
Yes, exactly. You can just start by adding more conditions, renaming your contract maybe to reflect its new use case. Maybe you would like to check for a token category there, so that you only allow to lock some Moria USD in such a contract and allow only spend with Moria USD, or extra authorization with a passphrase or whatnot. So idea first, I would not be tired to repeat this. You really want to implement your ideas and not to concentrate on trying to fight React in order to handle your just normally instantiated class and hitting the infinite re-render loops, and you know the deal.
Yes, no, that looked amazing, and I highly recommend everybody who is going to be getting involved in Blades to open that up, have a play around with it. It's still 2 weeks until the actual hackathon starts, so you can really get to grips with it, make sure you know what you're doing, and then maybe on the day, boom, you're ready to go, start that up and start coding on the 15th, but with that template already ready to go. Like that's very, very suitable, because the judges can say, okay, well, you started with this template, but the template wasn't doing anything advanced. It was just making sure that you didn't have to reinvent the wheel over and over, and you could get straight to the good stuff. So that's perfect, actually, to have that. All right. Okay, we had a few more slides, I think. First up is maybe an announcement.
Right. So the testing suite I've been covering here extensively was a part of the cache script package, but really it evolved with time, and I really want to make a hard suite out of it. If you know about the EVM coding, you know this tool where you start with the contracts, right? This is the testing suite of EVM world de facto, and I really want to evolve it past the present state towards more usability and less verbosity, because it's really verbose in terms of tasks definition and so on. So and of course, because it becomes a separate product, I'm looking for a cool brand name and a logo for it. And this is not my territory of expertise. So really, I would like to announce a bounty for a $50 about for the best idea, and some prizes for the second and third place. And it's highly subjective. I mean, if it's a very professionally done brand name and whatnot, and if I will not like it, I'm sorry, I do not like it. So yeah, jump in. be creative, propose me, and with this I as well wanted to activate you guys and get some feedback and make this evening day happy for you.
Yes, we can write this one up actually as a little quick doc and put it on the Dora Hacks page as well too. That's a nice little side quest for people who are involved in.
I've been thinking about the place where should this contest take place. I thought about your podcast channel, but I think Dora Hacks is well suited for that.
Yeah, we've got the other bounties listed up there. We can put that as a little bonus as well. Okay, that is looking perfect. All right, then we got one more slide, which is the conclusions. So tie it all together.
Yes, this is conclusions and takeaway for everyone. I hope I did not bore you. I've been trying to be very informative here and not rush through all the stuff, because there is plenty of information to consume here, to consider. So yeah, I just wanted to conclude that separating the application logic from signer is a powerful approach, and we should really follow it. In case of XO Stack, in case of Cash Connect, and be creative. Maybe you will invent a better Wallet Connect for BCH than Wallet Connect is, because it has its own ecosystem and it's more kind of targeted on the EVM world. Maybe we will have something which is far superior and well suited for our needs. And of course, there is even more stuff to do on this front, how to evolve this project and how to proceed. Like non-Wallet Connect 2 connectors, which you mentioned, private key connector for the UI. I mean, you could try to organize the secure storage in your local storage or IndexedDB, hash your secrets, and require a passphrase to decrypt it every time you need to do a signature. But still, private key connector UI would be, if you are familiar with Cauldron, that's the same. You connect a private key or Cauldron with a private key, you initialize it, and then you send your money there for a limited exposure to hacks and loss of funds, and then you do the trade on the side, and then you withdraw every time. So your keys, your coins, and you manage your own risks. And this private key connector UI, I thought about it back in the days when I've been developing the pump.cash or BCH pump, because if you are aggressive trader, like if you would like to be in the environment like pump fund it is, where you really, the timing is crucial on the market, right? If you want to sell at the right time, well, you will switch to a neighboring wallet page to sign your transaction request. You will maybe lose the competition and lose money, right? But having the private key connected to the site, you would be kind of faster with your decision making, right? And doing faster trades, maybe taking the edge of current situation and capitalizing on the market. So it's, while having some security implications, it really is or might be a choice of some. So this is, of course, a meaningful thing to do, not only for testing, right? Private key is currently only for testing, but then it will be as well for a kind of real world situations. Partial transaction signing requests, this is meaningful for more complex contracts and for the case where the dApp does not want to manage all the UTXOs of the wallet, right? It just wants to spend something or buy something, and then it will be uploaded to the wallet to pick the right UTXOs to fund those proposed transactions. And I have covered this already in my ongoing fundraiser. And check it out to support my efforts. And it's a funding campaign for the next year, but basically from now on, it's the scope is broad, and there is, because I already work full time. I want to work continuously full time without because previously when I was like running a campaign, I was kind of also funding my time off campaign, right? Campaign after its success. So for now, I wanted to reconsider and maybe go the Celine way, like you guys went, to just do it once and concentrate on work. And because I have seen this approach is as well more beneficial to everyone if you are really like running band of creating new software. You do not want to be kind of standing still. You really want to concentrate on building and not on funding yourself or asking community to fund yourself. So please consider to support my campaign. And I thank you all guys for your time. I had big fun today, and I hope I have educated some, inspired some. Remember idea first and go pursue your dreams.
Amazing. Okay. Yeah, definitely with Celine, it's been fantastic. And FundMe is now over 1,000 BCH raised across its whole lifetime. The podcast as well. It's an amazing platform. I recommend everybody check it out. And certainly you can get inspired looking at the ideas there. And maybe if you build a project at Blaze, you could then try and pitch it on FundMe if you had further ideas and you wanted to take it. Of course, we'll also be trying to help connect people up with investors and so forth directly, but the option is always there to go straight to the community too. So I have a couple of questions, but I don't see any in the chat. I don't know, Jet, if you have a question, or Carl. Okay, a couple of things then. Pat, talk to me just very briefly about the Layla upgrade. I really like you provided the framework here for people to use all the new tooling and stuff. I'm 99.9% sure that you have put in your endorsement for Layla, but I wonder if you could just speak to that. And I have the concept that maybe the BCH VM is in a way, quote unquote, like almost finished with the Layla upgrade. Of course, there will still be upgrades and so forth, but basically all the basic tooling is there for people to build whatever they want at this point. Is that right?
Yeah, I mean, this upgrade is amazing. I mean, it has so much stuff in it. And it has one of my desired upgrades within the P2S chip. It's the extension of the token commitment length, because 40 bytes was clearly poorly chosen. At least 64 bytes for a pair of 32 bytes identifiers would have been much better. But now we will have 128, so it's 4 packages of 32 bytes. So in my work, in my proposed work for cache script stateful contracts, this would mean 2 storage slots of 32 bytes variables. It's twice as much as I have desired. So I mean, of course, for variable length data structures, it is very beneficial to have this, but of course, this is very cool. P2S is very powerful as well in sense, if you speak about TapSwap or pump cache contracts where I create them, I always annotate this transaction with an extra op return output to define what did I create. So I create some P2SH contract, which is an address, and I don't know, without the knowledge of what I have put there, I will not be able to spend it. This is why I have encoded very minimalistically all the required information for it to be spent into the op return. And op return is, of course, I don't know, is a waste for such an information. If I would express this in a P2S format, then all the information will be already there in the contract lock-in bytecode. So I would just need to add some variables for the unlocking, right? Instead of fetching this from op return, make a heavy use of indexer. In this case, it's chain graph, which is as well requires some extra network calls to fetch this and so on. So it really streamlines the contract creation and spending. So for me, it's something amazing which I would never have dreamt about. So it's super I don't know, super cool stuff. I'm very excited. I can't find words. Bitwise operations is, of course, I mean, what is the programming language where you cannot manipulate with some numbers with bitwise shifts and make some power of 2 computations? And I mean, of course, it makes the VM more complete. What do we have else?
Loops and functions.
Loops and functions are essentials, of course. First of all, calling functions in loops. This is the level of building primitives we are so used to, right? Without this, I have this. If you did not check out this Orlando project, where I need to sum up all the token values from the inputs, I really had to unroll all these loops to like, be it 16 inputs with tokens. I need to execute the same logic. It's like copy paste all around, and the contract spending inputs are so heavy. So it's really suboptimal, and it's I'm sorry, but it's I don't know, kind of shame to be working in such conditions. But with loops and maybe what I would say, some syntactic sugar aggregation operations, that would be just hilarious. Of course, I would. For me, I declare that I want to work on the must contracts, and for this, I need to compute the Merkle trees. All the hashing information is, of course, done better with loops, but I already did propose the op Merkle for this exact case. Maybe, but if I think now about next extensions to the VM, it's all on the, like syntactic sugar or some comfort level. Like, you do not need to write code, but there is no issue with writing the verbose code anymore, because we have very stretchy limits which allow us, if you write basic code, you have all the space. If you do not hash like mad, then you do not expand the limits that much. So basic code will not contribute that much. So amazing times to live in. And I think with the activations of the chipnet of the new rules on the chipnet, everyone is encouraged to explore the new wide world of BCH. I mean, it's amazing.
Yes. Okay, a couple other questions. I know you've already been sort of touching on this in a way throughout this whole presentation, but I was wondering if you had any specific advice to new builders in BCH. Like, is there one stumbling block that you see people frequently get tripped up on, or one thing that you wish you'd known when you started that maybe you haven't already covered, or is maybe unrelated to the topic of what we were doing today? Just like one small piece of advice for all the people who are tuning into this stream who are going to be their first time building on BCH, and they're excited, but maybe they don't know where to get started, or there's so much going on.
Yeah, I think my advice would be, don't be afraid, don't be scared about some complexity, because it might be just imaginary complexity. Because if you would start to take a feeling of what you are working with, you read some docs and you understand the tool you work with. We really, as a community, we put a lot of effort for our tools to be useful. And of course, we as well spent some time to help others understand what they are using, not like hand-holding them and solving the tasks for them, but making them to get to know their tool, especially if we are the maintainers of the tools. And don't be afraid. Don't be afraid to fail, because if you fail, then you learn something. if you fail too hard, you can switch the tool to a competing tool. There is nothing wrong, because I'm an advocate of mainnet.js. There is nothing wrong to use BCH.js from PSF. This is highly competent people behind it, so, and they will consult you too. So there is as well now the AI era, and you can always ask AI to help you out, understanding maybe even what you see on the screen. But my advice is not to rely on the AI, especially when you learn. When you write the code and you just need some assistance to not spend some extra effort, then of course, but do not offload your learning, because otherwise you will not learn.
Yes, and one final question. Is there any particular project or idea that you're hoping to see come out of the hackathon? You've obviously got that bounty for an idea for the name of your project, but if you just could add something to the wish list that somebody would somehow make in Blaze, or maybe some inspiration or a theme to get started, what would you pick?
Well, within the context of the new chips, I'm not sure, because P2S is kind of esoteric, so it does not. So in sense, it's very simple, right? So there is my idea of annotating the P2S addresses with some external data, but I don't really see much more what you can do about it. Bitwise operations, of course, if you do a demonstrator of shifting the number by some bits, it's not really a wow effect or something like this. I would say this is already on a CashScript Team checklist, but these aggregation operations, or kind of a library of macros and functions which are like pastable somewhere, or some extra syntactic sugar to CashScript is very desired. I mean, instead of writing tons of code, you would just put some statement which will unfold for you. So, because while CashScript is very low level, of course higher level than the opcodes, still it has some space to expand and to be more user friendly and so on. I think maybe some will think bad of my idea, but I really think that we should pursue this idea of closing the gap between the EVM world and BCH world, to make the Solidity code compilable for BCH, so to say. And you will be amazed how many businesses will flow into our ecosystem, not because of fees or something like this, because I don't know, it's more performant. It is why not as well. I mean, if you think about this, and all this contention on the transaction level about the ordering, about the fee market and whatnot, and we have something to offer them.
Yeah, that would be amazing. Some kind of project that let people, import Solidity or do something like that. I don't know. Yeah, that's a great suggestion. And you're right. We definitely are wanting to attract people in from the wider world, and I think that's going to start happening. Okay, so we have a slide here to give a shout out to all of our sponsors. If you want to get more involved in the BCH ecosystem, these are some absolutely fantastic places to start, and we heavily recommend all of them. BCH Bull, a unique web application that allows users to take long positions with leverage or hedge with Bitcoin Cash against a number of other metals, fiat, and crypto assets. BCHbull.com. General Protocols, who make BCH Bull, pride themselves on delivering permissionless, trustless, borderless financial solution for the whole world. Working at the frontier of UTXO blockchain development at generalprotocols.com. The Bitcoin Cash podcast, combining the latest cryptocurrency Bitcoin Cash news with deep dives on BCH topics, featuring a variety of guests from the BCH community at bitcoincashpodcast.com. Selene Wallet puts easy, no hassle, instant payments in the palm of your hand. Experience the future of money, a global digital economy powered by BCH at selene.cash. Cash Stamps allows users to create and redeem BCH stamps for gifts, promotion, and adoption of Bitcoin Cash at stamps.cash. The Blockchain for Good Alliance harness the transformative power of blockchain technology to tackle some of the most critical challenges facing society and the world today at large. You can see the link tree on the slide, or chainforgood.org. BCH1 is the signal layer for Bitcoin Cash, community discovery, builder velocity, and capital alignment at bch-1.org. And Big Hair Tom, an old timer that wants wallet addresses simplified. Okay, we have a final opportunity to grab a cash stamp there. If anybody needs to pick up a few sats, and some final reminders to everybody: you can register on Dora Hacks, of course. All the information is there as well for you to dive into. We'll have our third workshop next weekend, Saturday, November the 8th at 6 p.m. UTC, so 4 hours later than this week and last week. That's the only exception. Otherwise, all the streams are at 2 p.m., but it will be at 6 p.m. to fit Callisti's schedule next week. That will be about the infrastructure of ChipNet and so forth. So add that to your calendar. If you want to find out more about Blaze, you can ask on the Dora Hacks question tab on Telegram at BCH Blaze or Twitter at BCH Blaze, and follow the podcast, bitcoincashpodcast.com, and the BCH Bullet, bchbullet.substack.com, in order to keep up with BCH. We have the full schedule there. So next week is the workshop number 3, and the week after that is when hacking kicks off on the 15th of November with the lock-in. All right, any final words, Pat?
Well, first of all, good luck to all the participants. A big thanks for the organizers. It's really very professionally organized, and I really like what I see. And yeah, I really had a blast participating. So maybe I will enroll and sign up for the hackathon myself. I'm not sure.
I hope so.
Yes, my pleasure, guys.
Thanks for coming on. This has actually been, unbelievably informative, and I'm so glad that now we have this recorded stream that we can refer people back to, and maybe also can be linked in the mainnet JS docs, showing a full walkthrough of how it all works. Absolutely amazing, very technical and detailed content. I think it's perfect for what builders need as they're coming to BCH. Okay, that will do it for today. Thank you, everybody, for watching, and we will be back on the BCH podcast channel tomorrow. We're going to have the BCH podcast at 5 p.m. UTC with John Moriarty from Bitcoin Out Loud, and then next week, Saturday, 6 p.m. UTC, workshop number 3 with Callisti. Thank you all for watching.